human egg, a few days after conception, is so small that if we go back to our pin, I could place the embryo, here we go, on the tip, the pointy tip of a pin. Which raises the question, when life is this small and this preliminary, how do we honor? Remember how small a life is at the very beginning. A fertilized human egg, a few days after conception, is so small that if we go back to our pin, I could place the embryo, here we go, on the tip, the pointy tip of a pin. Which raises the question, when life is this small and this preliminary, how do we honor what's here? There are scientists at Harvard, and you're going to meet them, who say it is sometimes right to use embryonic cells to investigate diseases and explore cures. Others say, yeah, but remember, this is a potential life, and we can't end that potential. That would be wrong. And we're going to show you very precisely what it is the scientists do to embryos so you can see for yourself. Because in the end, finding a balance between hope for cures and respect for life, that's the challenge. Here's our report from correspondent Patty Kim.
Lauren Stanford is a busy 13-year-old.
These ones are for like swimming. We won the soccer championships. That one, I think I got for high honors.
And she's got another major project, keeping herself alive.
At 7:15, I checked my blood. At 9:30, I checked my blood. 186. At 12:11, I checked my blood. Pull that up. At 3 or 2:45, I checked my blood. At 6 o'clock, I checked my blood.
So this is it, huh?
Yeah.
Lauren has type 1 or juvenile diabetes.
Oh, you're hiding.
She's had it since she was in kindergarten.
Oh, yeah, there you are.
A cup today.
Unlike some kinds of diabetes, type 1 requires constant vigilance.
Whoa, too much.
Counting carbs, checking blood sugar, and adjusting her insulin pump.
Make sure it's a good spot that doesn't have any scar.
What would you say is the toughest thing about having this disease in your family?
It's just invaded every corner of every member of our family. And everything that we're doing and she's doing is simply just keeping her alive.
Oh, wow. So how does this work? What does this do for you?
It gives me insulin. It's giving me insulin all around, like every 10 seconds I get insulin. And then
Even with all her high-tech gadgets, Lauren cannot control her blood sugar as well as a working pancreas.
Up into your arm, and there's a needle that actually goes into your arm.
yeah, but then you take it out and it's just
After
like
15 or 20 years with diabetes, the danger grows, possibly leading to kidney failure, heart disease, blindness.
That's the glucagon. You need it when you have like a seizure. I don't want to lose my eyesight. I don't want to have brain damage. I don't want to die of early age. Like, who does? Like, that's the only thing that scares me.
As soon as you change, you have to check your blood. Now.
But many scientists say that hope may be on the horizon.
I do think we can cure it, and our research has convinced me that that is going to be possible. Everything we learn says that it is possible.
Doug Melton has spent the last 7 years searching for a cure for diabetes. His work is personal. Both his children suffer from the disease. Today, he's optimistic about their future, thanks to a hot new field in medical research, which we've all heard about: embryonic stem cells. These are cells that have the potential to become nerve cells, heart cells, blood cells, any kind of cell in the human body. Melton, now co-director of the new Harvard Stem Cell Institute, wants to turn them into insulin-producing cells so they can help diabetics. So far, embryonic stem cells have been made mostly from frozen embryos left over from fertility treatment, and that on its own is controversial. But now there's a whole new way to make them that's drawing even more fire. It has to do with cloning. In February 2004, scientists in South Korea announced they had cloned human embryos and used them to create stem cells for research.
I said, wow, they've done it. I wish we had done it.
Good, good.
Dr. George Daly is a pediatrician who also studies stem cells.
The fact that that barrier has now been passed, I think really motivates a lot of other scientists to say, we can do it too.
Now, when most of us hear the word cloning, we think of the cloning of people, the stuff of science fiction films, both scary.
They are totally obedient, taking any order without question.
Dr. Eve.
And absurd.
He is exactly like you in every way.
Call him Mini-Me.
I don't know any credible scientist who wants to do that, who's working on that, and I think that we as a nation and as a world of community should outlaw that. There's really no reason to be doing that.
I think it's important that it's clear that we're not cloning organisms, that we're cloning cells, that we're trying to create cells, not children.
So if they're not making copies of people, what kind of cloning are the scientists talking about? Well, they say it would work like this. Start with an egg from a woman's ovary, remove its genes or DNA, then take a cell, like a skin cell, from a patient and put its DNA into the egg. This is called nuclear transfer. Add a few chemicals and the egg starts to divide, just like a fertilized egg. After a few days, it becomes a blastocyst, a ball of about 50 to 200 cells. If you wanted to clone a person, then you'd have to place the blastocyst in a woman's uterus. A similar process was used to create the famous sheep Dolly. But these scientists don't want that. So instead, and this is the step that causes so much controversy, they would break down the outer layer of the blastocyst. It's at this point, there's no turning back. The blastocyst cannot develop into a child, but the remaining cells can become embryonic stem cells, ones with the exact same genetic makeup as the patient. The potential benefits are obvious to doctors like Leonard Zahn, who sees a lot of patients needing bone marrow transplants. For 2/3 of them, there's no donor with an acceptable genetic match.
How are you feeling?
Even if a donor is found, the match is never perfect. Zahn says with cloning, scientists could, in theory, grow cells customized to an individual patient.
Thank you.
You used embryonic stem cell technology. You might be able to generate embryonic stem cells that have the same immune system as the patient. You'd have less chance of rejection, and we would hope that there'd be less death rate associated with that.
With cloning, this little boy, in theory, could get bone marrow cells that perfectly match his body. But there's much more to cloning than custom-made transplants. The thing that has scientists all over the world really excited is that cloning could allow them to do something completely new and different. Make sick cells. Now, why would they want to do that? Well, let's say you could take a cell from a patient, someone like Lauren. Create a clone. Let it grow in the lab until it's a blastocyst. Make stem cells. Then you could watch the cells as they get sick. That's exactly what Doug Melton wants to do.
Just like Abbott and Costello said, who's on first? When you're watching these cells develop, one of them is going to make a mistake first. One of the genes in the disease cell line is going to screw up, and we want to be watching it every minute to say who's on first, who screwed up first. If we follow those cells in a culture dish, we can get at the root cause of the disease.
If you could learn how Lauren's diabetes got started, you'd have a much better chance of curing it. This might work with lots of diseases that right now develop invisibly inside patients. Not just diabetes patients, but Parkinson's patients, Alzheimer's patients. That's why, instead of just studying healthy stem cells, scientists like Harvard's Kevin Eggen want to use cloning to create stem cells that are genetically predisposed to a disease.
Well, for certain diseases, it's true that cloning is the only way to do it. By taking cells from an individual which already has that disease, it does allow us to make embryonic stem cells that we know carry all the genes that are required for that disease.
This is one of the frontiers. It's enormously exciting research. It's very valuable. It's a whole fresh approach.
Uses a holding.
Nobody can guarantee that this approach will lead to cures. And even if it does, tangible results could be 5, 10, 20 years down the road. But right now, it's unclear whether these scientists will even get started.
This is the worst kind of science imaginable.
The Catholic Church, along with many pro-life groups, has been a major opponent of cloning.
Making human life simply to destroy it leads us right down directly on the road to barbarism.
The ayes are 265.
The U.S. House of Representatives has voted twice to make all human cloning a crime. If the bill becomes law, anyone who defies the ban could go to jail for up to 10 years and face $1 million fine. The measure is stalled in the Senate, but Senator Sam Brownback is trying to change that.
The president's ready to sign a human cloning ban. We've been blocked in the Senate. With the last election, we're going to revive efforts to try to ban human cloning.
President Bush supports some embryonic stem cell research, but only on a limited number of cell lines. He opposes cloning.
We should not, as a society, grow life to destroy it. And that's exactly what's taking place.
I personally believe that the nuclear transfer embryos that we create are, in a sense, not new life. I would argue that that embryo that's growing in a dish, just like many other in vitro fertilization embryos, doesn't actually have the potential to go on to become an individual unless it's transferred into the uterus of a woman who's willing to carry it to term.
When does that human life significance begin? We know biologically it begins at conception. That's when your life began. That's when my life began. If I kill you as an embryo, you're not here today. If you kill me as an embryo and research on me, I'm not here. So we know that biologically.
When does a human become a human with all the legal rights and protections of a person? Much of the debate comes down to this: a human blastocyst smaller than a grain of sand. Whether cloned or made from the union of egg and sperm, is it the same as a person? What are its rights?
What is a human embryo? What is a human clone? Is it a person or is it a piece of property? And most Americans look at this and they say, life begins at conception. And if that's so, that life, there's a sacredness to it and we shouldn't be violating it.
Oftentimes this issue is couched in terms of when does life begin. I think of it more of an issue of when does a person begin. And personhood for me is a process. The fertilized egg has the potential to become a person, but it won't necessarily become a person. Imagine you and I are sitting in an IVF clinic with my son and the fire alarm goes off. So now I have the choice of taking my son out of the room or grabbing a freezer with 100 fertilized eggs. Which would I choose? I think for me that emphasizes the difference between a real life, a person who exists, and a potential.
Both the blastocyst and the child are alive. Some scientists say we're approaching a crossroads where we, as a society, have to choose. What life do we value more? Lauren's mom, Maura McCarthy Stanford, is a Catholic and the parent of a diabetic child. Hopeful that the work might lead to a cure for diabetes, she supports cloning for research.
To me, that ball of cells is the miracle of possibility. It's the possibility of becoming a human being if it ends up implanted in a woman. It's the possibility of becoming cells to be put in my daughter because she needs to be cured of diabetes. It's the possibility of becoming the nerve endings for a spinal cord so someone can walk again. It hasn't made its mind up yet, of what to be, and therefore it is a possibility of all different kinds of life, whether it's new life or saving life.
That's correspondent Patty Kim with additional reporting by Deborah Amos. Remember how small a life is at the very beginning. A fertilized human egg, a few days after conception, is so small that if we go back to our pin, I could place the embryo. One of the most controversial science stories of the year involves stem cells, cells that may one day cure terrible diseases. But the problem with stem cells is they often come from embryos, thus the phrase embryonic stem cells. And embryos, while they start no bigger than a grain of sand, can become babies. So there is a moral issue here. But what if, and we're just going to think out loud, what if you could make an embryonic stem cell without creating an embryo? Could you? Should you? Well, we know someone who's trying. Reporter Julia Court has the story.
As he winds through the labs of MIT, Alex Meissner is trying to sidestep an ethical minefield. He hopes the tiny cells that float in his petri dish might hold the key to solving one of the biggest controversies facing science. Whether it's ethical to use cells from human embryos in medical research.
I believe this research has enormous potential, and it will revolutionize medicine in the years to come.
I don't want to live in a world, I don't think anyone wants to live in a world where we're destroying embryos, we're creating them and destroying them in mass quantities for research purposes.
While experts debated here, halfway around the world, South Korea seemed to be forging ahead. Last August, they claimed a spectacular first. A cloned dog. But since then, the Korean king of clones, Hwang Woo-suk, has been dethroned, accused of fabricating his results, including groundbreaking work cloning human embryonic stem cells. The Korean fiasco has cast a cloud over the field, but U.S. researchers still want to move forward, believing embryonic stem cells hold great potential for medicine, since they can become any kind of cell in the human body. But because they come from early human embryos, funding for the research is extremely limited.
Unfortunately, here in the United States, even though we're chomping at the bit to do the work, the kind of funding restrictions that we're under, the kind of presidential policy that we're under, is really the hindrance.
Physician and researcher George Daly is eager to create stem cells that are an exact match to sick patients. To do that, he wants to try cloning technology. But so far, the only cloned cells he's made belong to mice.
We're essentially frozen in time at 2001, while the rest of the world has moved forward very, very aggressively.
The controversial cloning process would work like this. Take an egg from a woman's ovary, remove its genes or DNA. Then get a cell, like a skin cell from a patient, and put its DNA into the egg. The egg is stimulated to divide, as if it had been fertilized. After a few days, the early embryo has 50 to 200 cells. The goal is to turn some of these into embryonic stem cells that would be a perfect genetic match to a sick patient. But because the cloned embryo would be destroyed in the process, critics say this research is wrong. With the destruction of human embryos at the center of the debate, a few scientists approached the new year asking if it might be possible to make both sides happy. What if they could find a way to create embryonic stem cells without destroying any embryos?
I think it should be doable.
Physician and ethicist William Hurlbut thinks the solution may lie in tinkering with the cloning process.
There's a way to get the cells without creating embryos. We just have to have the constructive conversation to find the way.
The challenge intrigued MIT's Rudolf Jaenisch, a leading expert on stem cells and cloning. With the help of graduate student Alex Meissner, Jaenisch tried to create something that would yield stem cells, but was not an embryo at all.
What is an embryo? What's important? I think an important part of the sense of an embryo is the potential to develop, to organize itself.
The Jaenisch team set out to eliminate that potential. First, they took a tiny bit of skin from a mouse's tail and let it grow in culture. With the skin cells growing in a petri dish, Meissner concocted a special virus and added it to the skin cells. The virus went to work and inserted an extra bit of DNA into the skin cell DNA. Meissner performed the cloning, sucking up a skin cell now containing the extra DNA and transferring it into a mouse egg. And then the team waited and watched. Jaenisch's hope was that the extra bit of DNA they'd added would shut down one key gene, a gene that's crucial for organizing the early mouse embryo and triggering the construction of the placenta.
The placenta, of course, is very important in signaling the fetus to develop. Without the placenta, it cannot. And the experiment worked very straightforward. It was actually surprisingly simple to us.
With that key gene turned off, the unorganized cluster of cells did not develop normally, and Jaenisch says would never become a baby mouse. But it could be turned into useful stem cells.
The real question is, does it solve the ethical problem? Some people said yes, others said no. It's a particularly devious way to murder an embryo. I would argue from the biological point of view, it is not an embryo. It doesn't qualify to be called this. It doesn't have any potential whatsoever to ever organize itself to a fetus.
Father Thomas Berg is encouraged by Jaenisch's experiment.
I think the jury's still out as to whether it's an embryo or not, but I think it's incredibly interesting from a moral standpoint, from a scientific standpoint, obviously. I think what Rudy Jaenisch did holds out some hope that those of us who do not want to live with a future of embryo-destructive research, we might have a way out.
But so far, there is no consensus about the moral status of what Jaenisch created among stem cell opponents or supporters.
The scientists who play along, I think, are playing the wrong card. They think, yeah, maybe if I'm clever enough, I'll satisfy all the critics. I think the critics are not going to be satisfied. I think they don't want to see embryonic stem cell research happen, and I don't think they want to see anything involving cloning happen.
Ethical objections have slowed U.S. research. Few labs have tried to use cloning to make human stem cells, and none have succeeded. The Korean scandal means that the technique for humans is unproven. But that, for many U.S. researchers, is all the more reason to keep moving ahead.
I have patience, and I can see a way to apply this technology to study their disease and perhaps treat their disease. I want to be able to use that process today.
If we get diverted into the debate about can we make a pseudo-embryo or an embryo-like thing, you could spend the next 5-10 years trying to figure out how to tweak an egg or play with embryos. I think to spend too much time trying to respond to every possible critic is a recipe for paralysis, not for breakthroughs.
One of the most controversial science stories of the year involves stem cells, cells that may one day cure terrible diseases. But the problem with stem cells is they often come from embryos. Thus the phrase